hands up anybody who felt that they got a little bit blindsided by the cloud. And before you put your hands up, let me explain that. So maybe you were running IT in your business and either the business or some developers came along and said, you know what, we've got all this stuff that we've been developing in the cloud and thou shalt run it in production tomorrow. Did anybody get blindsided by that? Because I know I did. Like 2 or 3 hands, really. Okay, well, I think if we're not careful, as we make the move to cloud, and we've talked about that a lot already, we risk getting blindsided by the requirement to run containers. So I'm worried that we get to the point where developers in the business come to us and say, we've developed all of these containerized applications, right? And now we need an infrastructure to run it on. And it doesn't run on thin air, right? And as IT, we'll then be asked to stand up highly available, resilient, secure infrastructures to run Docker containers, Rocket containers, whatever it turns out to be, okay? Anyway, this is me. So my name's Nigel. I podcast, I write books, I do training videos, and I talk on Twitter. But I only ever talk on Twitter about technology, right? So if you have any questions, if you want to talk to me about clouds and containers, reach out to me on Twitter. Really quick about the book, right? There's a million books out there for doing Docker if you're a developer, right? How to build a microservice web app. That book doesn't give a rat's ass about anything like that, right? That book is written for system administrators, people that need to stand up highly available, secure, and resilient Docker infrastructures. Anyway, standard disclaimer, okay? So container security, yet I'm not a security expert, so what's the deal, right? Why is somebody who's not a security expert talking about container security? Let me tell you, right, I've flown across for the day. I was in Berlin, I'm at ContainerCon. I would not give this presentation at ContainerCon because I'd get really hairy questions that I couldn't answer. However, I do know a thing or two about containers, and I know enough about security, okay, to give you a big picture so that you can go away and do a bit of research yourselves, all right? As well, I don't speak formally for Tech Unplugged, and I certainly don't speak formally for Docker, okay? So all of the rubbish that I make up here, it's just about me. Now, I want to just poll everybody in the audience first real quick, okay? But before we do that, does anybody know what this picture has to do with a container poll? So I Googled container poll because I wanted a funky graphic for here. And Google thought I meant container pool. Who knew you could do that with containers, right? You can do anything with a container. It's even got like little steps and stuff. Great. Anyway, so container poll, right? Please participate here, right? Who considers themselves a developer? One person right at the very back that I saw. Okay, hardly anybody. Thank you for being here. I'll moderate my comments about developers. Who considers themselves somewhat DevOps or in a DevOps environment? Okay, I'd say 15%. Who considers themselves 100% IT ops focused? Okay, about another third. What's everybody else? Okay.
Don't ask questions.
I know. Oh yeah, there's analysts and all kinds, isn't there? Hands up if you've ever used Docker. Check that out. That's like 80%. Mr. Chapman,
I saw it once.
yeah, I'm putting you to the test later. Hands up if you use Docker a lot. Ooh, about 5%, okay? Hands up if you've used Kubernetes, Swarm, or Mesosphere DCOS. About 20% of the audience. Okay. Last question. Who thinks that containers are not secure? What? No? Okay. Yeah. All right then. So I'm not going to spend a long time on this part of it, okay? But I just want to kind of set the scene, right? So this is what I would call the hypervisor model or the virtual machine model, right? We start at the bottom with a physical server. It's got disks, it's got processors, it's got RAM, okay? We power up a hypervisor. The hypervisor looks at those physical resources, rubs its hands, I'll have those, thanks, claims them all, slices and dices them, packages them up in a software construct that we call a virtual machine. Now, we'll talk about this at the very end, okay? That software construct that is the virtual machine, depending on the type of hypervisor you run, is quite often backed by some pretty cool hardware enforcement, so like Intel VT and AMD V, that kind of use hardware to back the isolation properties you get with a VM. Anyway, with a VM, every VM needs an operating system before you can run an application. Yes, this model is very secure, so breaking out of this VM and into this one is doable, and it's happened in the past, but it's a pretty secure model, right? But this is like, it's a big attack surface. It's fat that we could get rid of at the end of the day. So enter the container model, okay? We've still got the same hardware at the bottom, but we boot an operating system. The operating system does the same thing. It looks at all the hardware. It says, right, thou art all mine. And it claims it all, initializes it all. And then it builds operating system constructs on top, like higher level constructs. So instead of disks, you get file systems, right? So the operating system creates like a process tree, file system, network namespaces, and stacks and things. What a container effectively is instead of virtualizing the hardware, it virtualizes those operating system resources. And as a result, you can have a single operating system and a single kernel down here, get rid of all of that fat up there, and you can get, I don't know, more containers than you could virtual machines, blah, blah, blah. All right. Now, when it comes to security, okay, I'm going to cover quite a few things, right? All at a kind of a high level, though, right? We start out with an operating system. Now, the first thing we need to do is we need to secure it, harden it, right? But I'm not talking about the kind of operating system hardening that we used to do in the past, where that meant, I don't know, right, install the latest patches and probably remove Minesweeper and Solitaire. We're talking about a lot more than that, right? We're talking about properly shrinking down this operating system so that in the first place, the attack surface is as small as possible. In the Windows space, right, that would be Nano Server, which last time I checked was under a gig in size. Now, it's pretty big, right? But for Windows, that is pretty damn good. You know, a normal Windows, I think Windows Server Core is like, well, it's many gigabytes in size. So Nano Server, it's ripped out the GUI. It certainly doesn't have Minesweeper and Solitaire installed. This is like a proper, small, hardened operating system for developing containers. In the Linux space, try not to be too partisan here, but Linux is way better in this area, in my opinion. I checked I think it was yesterday or the day before, so Alpine Linux, it's like 100 meg or something. Snappy Ubuntu, like 150 meg or something. CoreOS Linux, like 200 meg. These are like small, hardened operating systems that are purpose-built for running containers and for working in the cloud. So they're bare bones, right? I've said they've ripped out all the libraries, all of the tools. You don't get 6 different shells to choose from. It's like, it's small and it's hardened. You can trust what you're booting. So for more detail on some of this stuff, right, go and check out what CoreOS are doing. But the first thing that we need to do if we want to secure the cloud and we want to secure our containers is we want to do things like we've got to be able to trust the code that we're booting. Effectively, right, if your kernel is tampered with, you can't trust anything else above it. So you want to be looking at things like signed bootloaders. Sign your kernel modules, right, so that if you've got a kernel module that's not signed, it doesn't get in there, right? Your initRD, you can sign that, package it into your signed kernel. You do all these kinds of really important things going forward to kind of create this secure substrate that we then build our containers on top of, right? So first of all, we've got our hardened operating system, right? Next thing is, I should probably have, instead of drawing containers there, I should have said processes, right? The next thing is we run processes on that operating system, but we isolate them, okay? So in the Linux world, we use kernel namespaces. All that really is it's a way of slicing and dicing that file system and the process tree, so that each of these processors or each of these containers thinks it's got the whole operating system, but it doesn't. This guy has no idea that this lady exists, and she has no idea that he exists. Okay, so we're isolating. Then we add C groups on top of that to kind of meter and monitor how much CPU, RAM, and disk I/O each of these containers can use, right? We don't want noisy neighbors. We don't want him trampling all over her and her walking all over him, right? On top of that, we can do things like, instead of the root process inside of a container or that a container runs under, having the ability to do everything on the machine, like reboot it and create new networks and all kinds of things, we can drop a bunch of those capabilities to say, you know what, the things that this container can do on the host down below, totally limit it. Mandatory access control systems like AppArmor and SE Linux let you take parts of the kernel and the operating system down here at the host level and say, you can't even touch that, you can do nothing on it. Then you can limit like the syscalls and stuff that your applications inside of your containers can make against the kernel. I don't want to get too deep into these things, right? But what we've got here is a bunch of stuff that if we use it, we can actually make these containers pretty secure. And a lot of these things are like kind of new. Well, look, they're not new, okay, but our ability to easily use them in the real world is getting better every day, okay? So like Docker and Rocket and LXC and the different kind of container runtimes and what have you, they implement most of these features here and offer you default settings that are pretty secure out of the box and are getting more and more secure over time. So this is kind of still hardening our operating system, right? But once we've got that, we need to be able to run software inside of these containers. We need to be able to run our applications, right? No point having this rock-solid operating system, but it can't run anything, right? Or what if we can't trust the code that's running on it? So in the container world, what we do is we pull images onto our operating systems, and from those images, we start containers. It's a little bit like, an image is a bit like a virtual machine template. You would spin a virtual machine up from a template, right? You spin up containers from images. Now, we pull images, yeah, okay. So we pull images from registries, which are just like I don't know, I would say a registry is like a glorified installation folder. I've got a folder on my laptop called installers that's got all of the software in I like to install. That's all a registry is, right? It's got all of your applications and your code that you want to run. But I want to do a quick demo with regards to registries, right? See if I can work this magic. I'm going to have to kill the presentation first. Okay. So this here is Docker Hub, which is a registry, all right? Now, if I click Explore up here, and assuming the network works, which it does, I'll just look up that Alpine Linux distribution I mentioned earlier, right? So Alpine Linux is what, it's in what Docker refers to as an official registry, right? An official repository. Now, official repositories, all of the images in an official repository, they're handcrafted to work in Docker, the images are signed, they follow best practices, they're well documented, all that kind of stuff. But if I take a look at this Alpine Linux repository here and look at the tags, I can see that every image in this repository is all green. And now that means it's been scanned, looked and compared against CVE databases for known vulnerabilities and exploits, okay? And this one's come up as clean. Now, that ability for me in IT ops to be able to say, right, Alpine Linux or Ubuntu Linux or whatever that we want to standardize on within our organization, I can go and look here. This is all pretty much real time as and when new vulnerabilities come to light. They get checked against these images, and if these images are vulnerable to, let's say, the bash bug, shell shock, or whatever, bingo, it would show up in here. Now, for me in IT ops to be able to look at that so easily and say, whoa, we've got these vulnerabilities is huge. Let me just give you a different example, right? So if I look at one of my repositories, this one here, this test repository, right? And if I look at tags, we're going to see the difference here, right? Look at the red, the orange, and the yellow there. And if I drill in a little bit deeper, I can see all of the different vulnerabilities in each layer of this image, right? Bunch of criticals there. I can link out to the actual detail of the vulnerabilities. Now, let me just say, right, it's... I've got to skip through a few slides here because I did put some temporary slides in just in case the demo didn't work. Yeah, let me show you how this works, right? So I have an image, I have some software, and I push it up to Docker Hub. That kicks off a trigger, which then says, oh, I'm going to take this image and I'm going to throw it over the wall to the scanning service. There's loads of moving parts inside of there, right? But I like to draw it as a cloud. Eventually, inside of the scanning service, it rips the image apart, it does a binary level scan, checks all the software and packages and things that are on there, compares them against the CVE database and gives me a report, which is this thing here, right? Now, when this first came out, I was like, oh, this is amazing, because the last time I worked for a real company, there was the shell shock bash bug, right? And we had to look across our environment and say, ooh, which of our systems are affected? And it was freaking hard to pin down what was affected. We had nothing like this. The problem is, right, be careful, because knowledge is power, but ignorance is bliss. And let me explain, right. It's one thing to go to your boss and say to her, hey, we can see all of the vulnerable code we've got in the environment now, and we can patch it, and we've got this really good view so that, you know, anytime there's a new vulnerability comes out, we can see what's affected straight away, and that's great. But then when she gets to see something like that, and she's saying, go fix it all then, it's a bit like, yeah, that's quite a lot of work. So just do be a little bit careful about that. Image signing as well, right? The ability to run your environment, and I'll show you a Docker environment in just a second, where you are unable to pull software that's not signed, can be quite powerful as well. And to be able to really easily sign it within your own organization, push to your own registries and things, so that your developers, even if they want to pull unsigned, non-legit code as far as you're concerned in IT ops, they can't do it, okay? So another quick demo, right? Yes, and I don't know the answer before you start, but...
Okay, well, it is related to the Docker Hub thing, and you just mentioned signing the code yourself.
Yes.
But I'm assuming that sort of an on-premise repository wouldn't have those extensive features in looking for the CVEs and so on.
Okay, right, so at the moment, with regards to Docker Hub, so Docker Hub is a public registry, it's out there on the internet, you don't run it on premises yourself. It's only available for private registries, and I think through the Docker Cloud platform that they provide. But I believe their on-premises registry, Docker Content Trust, if it doesn't, Docker Trusted Registry, if it doesn't already support it, the mic doesn't work, Enrico. If it doesn't already support it, it's on the roadmap to be supported in the future. So if you run an on-premises registry, and you know, if it's you know, a third-party registry as well, a bunch of those either do already or will support this kind of thing in the future. So I've just got a really small Docker environment running on my Windows laptop here, right? So for me, I'll just double check that I do actually. It does. Right, okay, so for me to turn on that image signing and force only signed images to be able to be pulled, all I have to do is export an environment variable, which I'm probably going to spell wrong, Docker content trust equals 1, okay? As long as that is set, if I then go Docker pull, and I try and pull some code from, let's try that one. Okay, won't let me pull the software down because it's not signed. But if I try and pull the Alpine Linux image, oh, dear me. Oh, yeah. Just as well, you guys are better at Docker than me. So, you know, for my next demo, I'm actually going to get an assistant. Okay, anyway, the thing is, right, so the image is pulling. It worked this time, right? I set one environment variable, and suddenly signing images is mandatory within my organization, not real organization, right? Okay, so we've talked about securing your operating system. We've talked about images and things like that, how to secure them. What about your infrastructure, though? You know, to run containers, you've got to have Docker hosts or Rocket hosts, or you've got to be running LXC or whatever, right? All of these hosts need to be secured. So, I'm going to do another demo. And this time, once I've got the demo ready, I am going to ask my superstar assistant to come up to the stage. As long as these sessions restart, we're in business. Can everybody see that, or does it need, like I've got a touch screen? Look at that. Right, so I'm going to invite the best dressed man in the room to come to the front, please. You know who you are.
Got this suit at Walmart.
Is that right? Right, so this young gentleman is the one and only Gabriel Chapman, who is a partner in crime of mine on the podcast that I do. Gabriel, speak loudly. Just tell people how much experience you have with Docker and how much of a great developer you are.
I can type hello world into Notepad.
That's the extent of Gabriel's experience. Okay, so take a seat at the console, please, Gabriel. Gabriel is going to build for us a highly available and secured Docker Swarm cluster, okay? So, Gabriel, if you please type Docker space Swarm space init, I-N-I-T, and hit return. Congratulations, stay there. So, Gabriel now has a Docker Swarm initialized. So if you type docker node ls, he's much better at typing than me. That'll do, just remove the hash. Yep, go for it, that's it. So we've got one node running, it's ready, it's available, and it's the lead manager, okay? Just switch to the tab at the top for worker number one. Do you see that tab close towards the top? So this is a work, skip back to the other one real quick. If you just cut and paste that like 3-line command in the middle, I'll show you where it is. That's the one, yeah. You have to go cut or copy. Paste that into the worker tab. Look at it, you didn't even have to press return, you captured the carriage return. This node is now joined as a swarm worker. Go back to manager one, run the same, the docker node ls command. It's going to be a bit low down now. Congratulations, you can take your seat back again, okay? You are now a Docker expert. The thing is, right? Oh, I didn't even get to use my cookies today, I forgot. It might not seem like that's much, okay? I kid you not, though. That right there, okay, it's only 2 nodes, but he could have added more workers, could have added more managers. The worker and the manager are both cryptographically identifiable within the swarm. The swarm has its own crypto ID. There's TLS configured on the back end here. The swarm, okay, so we didn't link to an external PKI or anything like that. It's a self-signed certificate, but it's on a 90-day rotation. Swarm will take care of rotating keys and everything every 90 days. But that thing is secure right there. Okay, now I just got the 2-minute warning, so I'm going to be in trouble. I actually think I'm finished my presentation, but what I want to say, right, is containers are slightly less secure than virtual machines, right? But they're getting more secure all the time, and if we build them properly, they can be very secure. Let's not forget, virtual machines are actually less secure than physical machines. There's no shared kernel between virtual machines in this environment, right? So I want to say one last thing, right? Oh, who knows what this is? It's not an onion. What? This, right, is a multi-layered security model for containers, okay? You wrap all of this stuff together, you put all of this in place, and you can run pretty secure container environment. But what about containers inside of virtual machines, right? I'm going to say let's have questions instead. If you want to talk to me about containers inside of virtual machines, look up Intel Clear Containers or talk to me later on. Any questions? But be careful, don't trust me, I'm full of... Oh, it's gone off the end anyway. So, how long, Enrico, 1 minute or?
Yeah, I have 2 minutes.
2 minutes. Questions? I'll repeat the question.
About the, I have two questions actually. One is the stickers.
Yeah, I've got stickers.
Fantastic. And the second one is on the management front. There's a lot of discussion about Docker Swarm or Kubernetes or Kubernetes, I think is the
Kubernetes, that's it, yeah.
preferred term. Which do you think is going to be
Yeah,
the winner in
it's a great question. So the question is, what's going to win out in the management and orchestration space? Is it going to be Kubernetes? Is it going to be Docker Swarm? Is it going to be something else? I don't have a crystal ball, okay? I hope going forward that both Kubernetes and the native Docker Swarm stuff both go on to be great, because I think we need at least two competing products to push each other to drive that innovation. So Kubernetes has massive support from Google, okay? And it has massive buy-in from the third-party ecosystem. The Docker stuff has buy-in from the third-party ecosystem as well, but also the fact that it's from Docker Inc. lends a lot of weight to it, because Docker is the container company. I mean, they're not, look, okay, I don't want to sound like a shill here, but you talk about containers, people naturally talk about Docker, right? So the Docker orchestration stuff, the Swarm stuff is not going to go away, and the Kubernetes stuff is not going to go away either. They're both great platforms, in my opinion. Any other questions? I hope that answered it.
No, that answers it.
Yeah?
Do you see container security being a developer responsibility or an ops responsibility?
So I think it's both, actually. When it comes to like the image signing and stuff there, I would anticipate that IT ops would say, we have a base layer image of sorts that you build from, okay, whether that's Ubuntu, Linux, whether it's whatever, right? We sign that, we own it, and we provide it to the developer community. But then the developers are then going to go and pull packages and, you know, add layers to that image. They have their own burden to bear there. I think tools will develop around that let you enforce that organizationally, you know, across the whole organization that says, you know, before you add something into a trusted build, it's got to be vetted. So I think both bear an element of responsibility there. Thank you.